The aim of this experiment is to empirically measure the Kc for the reaction of iron with a thiocyano ion to form the intensely colored complex of monothiocyanate iron. The reaction is shown here for your benefit. The color formed by this complex has been referred to as blood red, but really is more of an orange red. The Kc value will be estimated by adding successive additions of iron to a constant amount of the thiocyano ion to produce an increasingly darker red color. The intensity of the red color can be measured with this instrument, a spectrophotometer, which measures the absorbance of light by ions and molecules. In our reaction, the complex absorbs light at 455 nanometers. We'll tell you more about this instrument later in the video. You'll collect about 10 to 12 data points of different intensity of light and then use a derived equation to estimate Kc. Don't get too scared of the equations and the derivation in your laboratory manual. We'll use equation 7 and the plot associated with that equation to help estimate Kc. Now let's turn our attention to some practical aspects of this experiment. First, we'll look at the reagents and the glassware. First, notice that there will be three main reagents: the stock potassium thiocyanate, 2 molar nitric acid, and 0.1 molar iron nitrate that is also prepared in nitric acid. Remember, the iron solution also contains this nitric acid to prevent the formation of insoluble iron hydroxide. Second, note that you'll be using a 1 milliliter volumetric pipette. We've previously discussed how to use this device. In addition, you'll be using a 100 milliliter volumetric flask that is similar to the pipette in that it measures a fixed volume of solution. The flask also contains a graduation mark to denote the fill line. So if you fill the flask with a solution to the graduation mark, you get exactly 100 milliliters. We'll demonstrate using the volumetric flask with a solution of colored water. To fill a volumetric flask, you'll probably want to use a plastic funnel that you can find in your drawer. So insert the plastic funnel into the neck of the flask and then pour solution from a beaker or other container into the flask, and pour it slowly and allow the solution to carefully drain into the volumetric flask. One of the things you'll want to do is fill the flask about 90% of the way full or so. Then once you get close to the graduation mark, you want to use a transfer pipette, one of these plastic pipettes which you may find in your lab drawer, and just simply suck up a little bit of solution and then start to drip it into the flask to avoid overshooting the graduation mark. And now you can see that we have a full flask. We'll use the spectrophotometer to measure the absorbance of our solution. In order to use the spectrophotometer, we'll want it warmed up for 15 minutes. There's a switch on the back to turn it on, but typically your lab instructor or lab TA will have it warmed up for you. After the warm-up period, you can set the wavelength with this dial. In our experiment, it's 455 nanometers. You'll also want to make sure the instrument's in the absorbance mode. In this case, it's actually in percent transmittance, so we use the mode button to switch it so that the little red light's beside the A for absorbance. Now we're ready to use the instrument. First, we need to blank the instrument, and we're going to use this cuvette, which is a specialized test tube that's been filled with distilled water to blank the instrument. And so we just use a chem wipe to wipe off the cuvette, make sure any moisture is gone, and then we insert the cuvette into the sample chamber. You want to try to insert the cuvette the same way each time. We're going to give you a tip in just a second to help you with that. Close the lid, and then you want to press the 0A button. And this is zero absorbance, and you press the button, and the letters BLA come up, and that stands for blank. And so right now the instrument's blanking itself against water, or said another way, it's eliminating absorbance that's due to water or even light scattering due to the cuvette. The BLA will blink a couple of times, and then 3 zeros will come up, and that means that we successfully blank the instrument. So you remove the cuvette with water, and you take a second cuvette, and empty one, and you pour in your solution, and you should fill it about 80 to 90% full. You'll also want to use a chem wipe to wipe off the outside of this, any moisture, and then insert the cuvette in the instrument. Again, try to do this the same way each time. And then for the sample, all you need to do is read the absorbance value. In this case, it says 0.461, and that's a typical absorbance value. Typically, they're between 0 and 1, and you just need to write that number down. No need to press any buttons. And so this is one data point. and you're going to collect about 10 to 12 data points in each way, and each time you should blank with water and then put your sample in and read its absorbance. Here's a tip to help you insert the cuvette the same way each time. On your cuvette, use a Sharpie marker to make a small line at the very top, and then insert the cuvette with that black line facing the front of the instrument each time. Now we've shown you how to use the instrument, and you'll use one like this in lab. However, we want to show you the inner workings of an instrument, and a slightly older one like this will allow us to see under the hood a little bit easier. Before we take a look inside, let's take a look at this schematic. First, the light source. In our case, this is a lamp. Light coming from the lamp is directed by a mirror to the grating. Here the grating will break the light into the individual wavelengths and then direct the light to the sample cell. The sample will absorb some of the light. The rest will go to the detector where it is detected. The signal coming from the detector is then converted by electric meter into a useful signal, which in our case will be absorbance. Now that you've seen the schematic, let's take a look at the inside of this instrument. And so we'll just pull off some of the knobs and this cover, and right away you can see some gears and a computer board, and these all work together to help make this instrument work. First, let's focus on the lamp. This is a spare lamp that we have, but there is one in this instrument, and as I turn this around, you can actually see the light coming from the spot right here. Again, the lamp looks like this. In the instrument, it's positioned horizontally, and you should see some light coming out of here and perhaps the back of the lamp. We've rotated the instrument and elevated to help you see the insides a little bit easier. Just to orient you, the lamp sits right under here. Any of the light that comes from the lamp is then channeled into this light tunnel, and the purpose of the light tunnel is just to capture all the light and to focus it down to the grating, which sits right under here. Remember that the grating will break the light into various wavelengths and then bounce it in the direction of the wavelength came. From this angle, if you look right under the arrow, you can see that the grating has indeed broken the light into various wavelengths. As I turn the cam, you can see we are selecting for different wavelengths of light to send to the sample cell. The particular wavelength of light then makes it to the sample cell here. The sample will absorb a certain amount of the light. Any light that's not absorbed by the sample makes it to the detector. The detector then converts that signal into an absorbance reading, which you see here. In this video, we'll be giving you a few demonstrations and tips to help you complete this experiment more easily. You should also remember to always wear your safety goggles or safety glasses, and we'll see you in lab.